Welcome back, Digital Defenders, to the final trials. You've honed your skills, you've battled the bugs, and now you're standing at the edge of your biggest challenge yet. It's time to become the master of your own creation.
You've come such a long way on this coding quest, and now there are just 2 final tutorials standing between you and building your ultimate Digital Defender game. Seriously, think of these as the final 2 levels in your training. Let's get into it. But before we jump into the new stuff, let's just take a second. Let's appreciate the incredible toolkit you've already put together on this journey. You've unlocked some seriously powerful abilities.
Okay, so check this out. Every single game you've made so far has basically been a secret cybersecurity training mission. Remember Clovercatch, those collision checks you built? Well, that's the exact same logic used to see if a hacker has bumped into a secure file. The loops in the chasing game, that's like an antivirus, constantly scanning. And finding your way through that 80s rockstar maze is just like tracing a digital footprint through a network. See? You're already thinking like a cyber defender.
All right, let's get to the first of our final challenges, the RPG adventure. This one's all about leveling up your understanding of the more abstract side of coding. You know, things like system state and telling a story with logic.
So the big idea here is something called state. Now, don't let the word fool you. It's actually super simple. It's just the current condition of a thing. In cybersecurity, a network state could be secure or it could be compromised. In our RPG, we're going to use game mechanics to actually represent and change that state.
And this is where it gets really interesting. Look how this table breaks it down. State tracking in the game, like keeping track of your inventory, is a perfect way to model the security status of a real system. The dialogue? It isn't just a story. It's like getting a pop-up from a system administrator warning you about a threat. And the conditional logic? If you have the key, then the door opens. That's the absolute foundation of how secure systems work.
And this just nails the whole idea. Think about it, right? When you pick up a key card in a game, you've just changed your state. You now have access you didn't have before. Your game inventory is literally the set of keys and permissions you have to get around in the digital world you've built.
Awesome. Now for the second trial, the platformer. We're going to shift gears from that abstract world of logic and state to the more, physical world of movement, gravity, and jumping around complex, layered environments. So a key concept here is the hazard. You know exactly what this is. In a game, it's the spike pit, it's the enemy you have to dodge, it's anything that poses a direct threat to you. And in the world of cybersecurity, the parallels are pretty obvious. Okay, let's really dig into this one. Those different platforms and levels you're jumping between, think of that as your layered cybersecurity defense. You've got a firewall, then an antivirus, then user permissions all stacked on top of each other. Your character's movement, that's basically data traveling across a network. And those hazards? Yep. They're the malware, the viruses that your little data packet has to skillfully avoid to get where it's going safely.
And there you have it. That's the core idea right there. Every single jump, every dodge, is like a piece of information successfully navigating all the dangers of a network. You're not just coding a game, you're simulating the journey of data through a defended digital space. Pretty cool, right?
Okay, now this is where it gets really exciting. You've mastered the abstract logic of an RPG and the physical mechanics of a platformer. So what's next? We combine them. This is how you create something truly powerful and complex.
So, just look at how these 2 skill sets line up. On one side, you've got the RPG's brainy, abstract ideas, state, inventory, dialogue. On the other, you have the platformer's physical rules, gravity, hazards, movement. They seem totally separate, but the real power, the real magic happens when we make one side affect the other.
Let's walk through this example right here, because this is the whole point. Step 1. Your player collects an item. That's a classic RPG inventory mechanic. This changes your player's state. Because that state has changed, a new dialog box unlocks. But here's the magic trick. In step 4, that abstract logical change gives you a new physical ability. Now you can jump over a hazard that you couldn't get past before. Your logic has literally changed the laws of physics in your game.
And that's it. You've done it. You've passed the final trials. Now, with your complete coding toolkit, it is time for the final step, to build your very own, totally unique Digital Defender game.
I mean, just look at this. Every single skill you've learned, from that very first collision check all the way to managing gravity and dialogue, it's all yours now. It's at your command. You have everything you need. All systems are ready for you to create something incredible.
So, I'm going to leave you with this question.
With all of these tools, all these concepts at your fingertips, what kind of defender will you build? How are you going to combine logic and physics, story and action to protect your digital world? The choice is yours. Now go build.